All right, let's just jump right in. For more than 40 years now, this tiny little machine from Earth has been sailing through the dark on an incredible journey to the very edge of our solar system. And what it found out there? Well, it completely upended what we thought we knew about our home in the cosmos. It revealed a wild, turbulent frontier and a mysterious wall of fire.
So it really makes you wonder, right? Where does our solar system actually end? Is it just where the planets stop, or where the sun's gravity finally gives out? The answer, it turns out, is way more complex and honestly, way more interesting than that. It's not a line in the sand, it's a place. A huge, invisible bubble that wraps around us, separating our little neighborhood from the rest of the galaxy.
And that bubble, it has a name, the heliosphere. The best way to think of it is as the sun's own personal atmosphere. It's constantly being inflated by this stream of charged particles called the solar wind. And this isn't just empty space, it's a massive magnetic shield that protects every planet, including us, from a constant barrage of nasty, high-energy cosmic rays. You could say it's our own little lifeboat in a vast cosmic sea.
Now this is where it gets really cool, because you can actually understand this enormous cosmic structure with something you see every single day. Just picture your kitchen faucet. You turn on the water, right? You see how that stream hits the bottom of the sink, spreads out super fast, and then runs into this kind of circular wall where the water piles up, gets all turbulent and slow. Well, believe it or not, that's the heliosphere in a nutshell. The fast water is the solar wind, and that turbulent ring around the edge, that's the boundary, where our sun's influence literally slams into the great wide open of the galaxy.
So, to actually go out and explore that edge, we needed a detective. A tough little probe launched way back when cassette tapes were a thing and sent on a one-way trip into the great unknown. Its name? Voyager 1.
And man, what a road trip. After completely rewriting our textbooks on Jupiter and Saturn back in the late 70s and early 80s, Voyager 1's main job was technically over. But its journey? That was just getting started. In 1990, it got a brand new mission. Just keep going. For decades, it flew in silence, heading straight for that cosmic shoreline we just saw in the kitchen sink.
This quote from NASA just nails it. Voyager 1 basically became our message in a bottle. It's this lonely little life raft we tossed overboard from ship Earth to see what the currents are like out there in the interstellar ocean. It's our remote sensor, our eyes and ears in a place that we ourselves can't get to yet.
So how does a tiny spacecraft billions of miles from home even begin to survey cosmic currents? Well, it does something you might not expect. It listens. And what it heard was something nobody could have predicted. Yeah, you can forget that idea of space being a silent, peaceful void. It is not even close. The space between the stars is a churning ocean of plasma, full of gigantic waves from exploding stars and the slow, powerful churn of the galaxy itself. And Voyager 1 was about to dive right in. But before it could reach that interstellar ocean, Voyager had to get through the cosmic equivalent of crashing surf. First, it hit something called the termination shock. That's the wall of water in our sink analogy, where the solar wind crashes from supersonic to subsonic speeds. And then it plunged into the heliosheath, this chaotic, foamy, bubbly region of compressed energy.
It's a real mess out there.
So Voyager's key tool for this part of the trip is its plasma wave subsystem, which is basically a fancy name for two giant 30-foot antennas that kind of look like bunny ears. They're designed to listen for the hum of plasma. See, as waves move through space, they make the electrons vibrate, or ring, kind of. And the pitch of that ringing sound tells scientists exactly how dense the plasma is. It's a pretty simple rule for a really complex place. The higher the pitch, the denser the space.
For years, scientists waited. They were just listening to the data, waiting for that telltale sign that Voyager had finally made it, that it had crossed over. And then, in 2012, the call finally came in.
The evidence was just undeniable. Okay, so first, on August 25th, the instruments that measure particles from our sun suddenly saw the numbers drop off a cliff. At the exact same time, galactic cosmic rays, particles from outside our solar system, spiked. The shield was down. Then, a few months later, those bunny ears picked up a faint, new hum. And finally, in April 2013, the hum came back. Only this time it was louder and at a higher pitch. That frequency jump confirmed it. The density of space around Voyager had just jumped by 40 times.
And this is what gives you goosebumps about science. On the left, you're seeing a radio event from way back in 1993. It was caused by a solar flare hitting the edge of the heliosphere. Scientists used its frequency to predict what the density should be right outside the bubble. Now fast forward 20 years, Voyager 1 finally gets there, and as you see on the right, it measures a plasma hum at almost the exact same frequency they predicted. Just think about that, a prediction confirmed 2 decades later across billions of miles of space. Incredible.
So, the evidence was in. The case was officially closed. Voyager 1 had left the building, or, the heliosphere, and was now sailing on the interstellar sea. But just as one mystery was solved, the data started sending back something completely baffling. Something that no scientific model had ever predicted. Something shocking.
Immediately after it crossed that boundary, Voyager found itself in a region so incredibly energetic. Scientists have nicknamed it the firewall.
The instruments on board measured the temperature of the particles out there to be somewhere between 30,000 and 50,000 degrees Celsius. Let me just repeat that. Up to 50,000 degrees. That is about 10 times hotter than the surface of our own sun. An unbelievable wall of fire right at the edge of our solar system, which of course leads to the one question everybody asks. How on earth could a machine built with 1970s technology survive temperatures that can melt pretty much anything we know of? I mean, it seems to just defy physics. But the answer is actually in the difference between two very simple words: temperature and heat. Now here on Earth, they're pretty much the same thing, but in space, they're totally different. Temperature is really just a measure of how fast individual particles are zipping around. And yeah, out there they are moving at incredible speeds. But heat is the transfer of that energy. And because space is almost a perfect vacuum, there are just too few particles, they're too spread out to actually bump into the spacecraft and transfer any of that energy. So something can be insanely hot in terms of particle speed, but not feel hot at all.
Here's probably the best analogy to help you wrap your head around it. Picture sparks flying off a metal grinder. Each one of those little sparks is thousands of degrees hot, right? But if one of them lands on your hand, it doesn't really burn you. And why is that? It's because it's tiny. It's so small, it doesn't have enough mass to transfer any real heat to you. The particles at that firewall are exactly like those sparks. Individually, they're super hot, but there are so few of them and they're so spread out that they're basically harmless.
So what have we learned from this little life raft on its incredible voyage? Well, we've learned the edge of our solar system isn't some nice, neat line. It's a complicated, turbulent frontier. We know for a fact now that the space between the stars is about 40 times denser than the space inside our little bubble. We also learned, kind of surprisingly, that the sun's magnetic field seems to line up perfectly with the galaxies at this boundary, which is a huge puzzle for scientists. And get this, we've even learned our heliosphere might not be shaped like a comet after all, but more like a deflated croissant. Voyager 1 and its twin Voyager 2 are still going. They're pushing deeper into that interstellar dark, still sending back these little postcards from the void. They've answered questions we didn't even know we should be asking 40 years ago. And they've shown us that even at the very, very edge of our home, the universe is just full of secrets waiting to be found.